In the chapter 31, you're going to evaluate the information in tables, charts, and graphs using statistics. You have many objectives for this particular chapter, so make sure you understand all of them. Calculate measures of central tendencies. In other words, can you find the mean, median, and mode of a list of data, which you may already be familiar with. You're going to calculate the range. You're going to identify the spread of a data distribution. You're going to identify the shape of a data distribution. You're going to identify a trend based on a graph or table of data. You're going to explain a point on a graph, chart, or table in terms of a given context. You're going to identify expected and unexpected values, which are outliers. And to be successful on the TEAS test requires that you understand some basic concepts and carry out basic statistical calculations. Before we get started in the book, there's a few key terms that are listed on my lecture notes that you need to be familiar with. A data trend is a general tendency of numbers in a set. Expected values are the most likely value of a random variable. Measures of central tendencies, which we talked about as the mean, the median, and the mode. We'll get more in depth in those in a few moments. An outlier is a data point that is distinctly separate from other data or an unexpected value. The point on a graph is the location of a value expressed as XY ordered pairs. Your range is the measure or spread of a data set. It is the difference between the highest and lowest values in a set. And your shape is based on symmetry, the number of peaks, skewness, and uniformity of data distribution. We'll talk about each one of these in a few moments. And your spread reflects the variability of the data. Now that we understand these key terms, let's actually start talking about the central tendencies. The measures of central tendency are your mean, your median, and your mode. This is the definition of how you determine how to find each one of those. And this is an example. We'll actually do an example in a few moments. The range is the measure of spread for a data set. So to find the range, you subtract the minimum value from the maximum value, like we talked about in the key terms. Your symmetry is a symmetric distribution can be divided at the center with each half mirroring the other. So if I split this right down the middle about at 50, 51, half of the values are going to be on this side, half of the values are going to be on this side, and they're going to look kind of like a mirror image of each other. The distribution of data can have few or many peaks. A distribution with a single clear peak is called unimodal, and a distribution with two clear peaks is called bimodal. So this particular graph here, it kind of goes up, and then goes back down, then it goes back up again. So it has two peaks, so it will be considered to be bimodal. Now a bell-shaped is unimodal. That means it just goes up and then comes down in the graph. And like you can see in this bar graph, if we drew a line going from the bottom all the way up to the top, and then it comes back down, this would be what we call a bell-shaped curve because it's a normal distribution. In some graphs, when you graph the distributions, they have more observations that fall on one side of the graph compared to the other. So distributions with fewer observations on the right or upon the higher side towards the higher values are called skewed right because you have less high values on the right. But when it's skewed left, it's just the opposite. You have most of your observations on the right and very few on the left or towards the lower values. So these are considered to be skewed left. You could also have a graph that has the uniform distribution, which means they're spread equally across the range of the distribution. This is called a uniform distribution. It has no clear peaks and no clear valleys. So you can kind of see it just kind of levels out. They're all over the place. You may also be able to tell from a table if you have a trend or not. Data sets in a graph or a table also reveal trends or patterns in the data. Data trends are usually easy to see in a simple data table. So we can see in this particular one, the value of X has this value. And then as you start going up higher on X, your Y value gets to. Then when you get to 6, it gets to 100. But then after 6, it starts going back down. So the higher the X value, the lower the Y value. So this one's kind of one of those graphs that may go up and then kind of come down. This is what the trend would be. Now what you understand is that trends can be more difficult to find in complicated data tables. This one only had 7 different items, well 6 different items. If we have a data set that has, say, 100 or 50 even, we may not be able to see the trend as easily until we actually graph them. So in this particular graph here, I'll let you look at it. It starts out at 1, has this particular value. Then it kind of goes up, then it kind of comes down, but not always at the same level. So dataset models can reveal what are known as expected values and outliers. An outlier is an unexpected value that does not fit any trend or pattern in the data. Now in this particular example here, we don't have any outliers because it kind of follows along a particular line. But in the next example, we do. So let's look at this particular graph. All points in the graph follow along the trend curve except the one that is way above the rest of the data. So you can kind of see all the other ones in this particular data set are kind of bunched around this line if I drew it out here, except this one guy or one person way on out here, this one data point way on out here. It's outlined. It's not near any of the expected values. We could also have one that be way down here would also be an outlier, even though it's under the line. So anything that just doesn't sound normal or is what they call not an expected value, you would call those outliers. We're now going to work an example for central tendencies. Remember, central tendencies are the mean, the median, and the mode. This example is also posted as one of the handouts in the chapter in Canvas, so you can always go there and print it out again. But a normal resting heart rate for adults ranges from 60 to 100 beats a minute. So the following pulse rates were recorded for a group of 15 students. These are all the different values. As we can see, they range between 60 and 100. So we got a low of 61. Then we have a high of, let's see, where is the high? 86. I think that's right. So what I want you to do is I want you to stop this video for a few moments. Go out there and find the mean, median, and the mode of this particular list. Then come back and check the answer. Okay, hopefully it didn't take you too long to do this particular example. And if you forgot how to find the mean, the median, and the mode, go back to the table that's in your book on page 190, and it'll show you how to find the measures of central tendencies by their definitions. But to find the mean of the list, remember the mean is just the average of the list. So all I had to do was just add them all up and divide by 15, which is the number of students I had. So once I did that, and I checked my math, I get a 72.8 is my mean for this list. Now to find the median of the list, first thing I had to do was, since these numbers are not in numerical order, I had to put them in order first. So once I did that, you will see my list here. Now we have an odd number 15, so we'll only have one middle number, which happened to be the 8th number in the list. So I counted 1, 2, 3, 4, 5, 6, 7, 8. And this would also be the 8th number from the opposite side. 1, 2, 3, 4, 5, 6, 7, 8. So once I found my middle number, that's my median. Now if I would have had 16, then I would have had two middle numbers, and the way that I would have found the median would be take the average of the two middle numbers. But since I had an odd number, I'm only going to have one median. Made it a little bit easier on myself. Now to find the mode of the list, which is the most listed number or numbers in the list, I had to look back and see how many times each one of these individual numbers was listed. Now 70 is listed twice. 71 is listed twice, but all the other numbers are only listed once. So 70 and 71 are each listed twice, and all the other numbers are only listed once. So my mode is 70 and 71. In some examples, you may have no mode where every number is only listed once or listed the same number of times. You can have only one mode where one number is listed more than any of the other ones, or you can have multiple modes where they're all listed the same, except there's going to be some numbers listed less than that. So good luck in this chapter, and hopefully you won't have any problems with the mean, median, and mode. Like I said, you may already be familiar with this, and you may have been taught a little bit different way to find it, but as long as you get the right answer, we're still good. Good luck on the chapter again.